result of the heterogeneous and the anisotropic condition of the rock that is being fragmented. So due to that, there tends to be a dislocation between two rock particles, rock grains, rock minerals that is receiving the same quantity of energy at the same time. So the strength of each mineral grain tends to vary due to their heterogeneous condition. As we all know, mineral is composed of different elements and rock is composed of different minerals. Like the way the response that quartzite, like that quartz will give to a shock wave of the same quantity energy will be different from the same response that calcite of Agnes 3 will give to the same energy that is passing through it. So rock tends to fail at blasting also under shearing due to that condition. And also the last one, which is the tensile, rock tends to fail under tensile strength due to the reduction and the very little tensile strength of rock, which is very minute. So this tends to occur under what is called body movement. So number one effect of maximum building is the environmental impact. If I say environmental impact, I'm trying to say the possibility of the blasting causing damage to the environment beyond what we are expecting, like in the place of the fly rock, in the place of the ground vibration, in the place of every other effect like the noise. So one thing about budding is that increase in budding tends to affect spacing. Then if spacing is affected, then there's possibility of you charging the ore beyond what you are expected. During detonation, there's the release energy from the explosive moved basically in three directions. One, in the upward vertical direction, that is upward vertical direction, and in the downward vertical direction, then in the horizontal. If there is increase in budding, which also automatically affects spacing also, the explosive energy tends to migrate or tends to escape from the blasting zone through the weakest zone. So the weakest direction tends to absorb more of the energy. So if the blast release energy try to move horizontally and there's high obstacles that is obstructing it, then it tends to decide to blow up in vertical direction upward, causing fly rocks and also causing a release of dust and high decibel of noise. So the environmental impact of blasting due to maximum budding cannot be overemphasized, as it's highly possible for blasting to cause more of environmental impact if the budding is too much. The budding, as it stands, the weight on the blast energy. If the budding is too high, then the energy tends to misbehave. Then if the energy tends to misbehave, then it will actually perform other works that we are not expecting the energy to perform, in the place of projecting some of the rocks, trying to find its way vertical upward instead of penetrating into the rocks, trying to create micro cracks and place of the gas energy filling the micro cracks and breaking down the rocks. So the environmental impact of blasting can be as a result of maximum or excessive budding. As I've said earlier, budding is related to spacing automatically directly. If it is squared, drilling pattern is directly, that is, budding is equal to spacing. But if it is staggered, we know it's range from 1.15 to 2 times the budding. So spacing is having relationship, is directly proportional. As soon as budding increase, spacing increase. As soon as spacing increase, the energy release and distribution within the ore tends to reduce as a result of high budding on the rock, on the explosive energy, which can automatically cause the explosive energy to be released at wrong direction. So when for example, if the explosive energy tends to move like this, so as to fragment the rock or breaks the rocks, so as to create cracks for the gas energy release after detonation, after detonation to fill the cracks. In the means of trying to crack the rocks, if the explosive energy tends to see that there's more budding in a specific direction, it tends to reflect to another direction, or the energy at detonation tends to blow up or cause a fly create loss of fly rocks, of which we are not interested. That is control. We are trying to control the environmental impact. We are trying to control the effect of blasting on the environment. So since we are not interested in the blasting resulting into fly rock, in the blasting resulting into more of ground vibration, in the blasting resulting into more of noise, which can affect human being directly, so we are interested in creating such a body that will create less of load, of which the blasting can respond to without any environmental impact. Apart from that, an increase in burden also affects the powder factor directly. An increase in burden will cause an increase in spacing. So an increase in spacing will cause an increase in hole diameter, which result at increase in charge length. So if there is increase in charge length, then there will be increase in the quantity of explosive used to detonate one tonnage or 1 cubic meter of the rock. So we are interested in performing our blasting in such a way that the powder factor will be very minimal and will be effective. It will not be less effective, but be effective in such a way that the fragmentation will be at the optimum size with less oversize and less undersize lesser than 5% of the whole mock pipe. So for us to achieve that, if our burden is Sx, then we have issue with our powder factor, because we will be interested in making the powder factor to be such a powder factor that will cause more of the rocks to be effectively fragmented. So if our powder factor tends to increase, then we are still going to tend to the direction of environmental impact and to the direction of economic effect. We know the price of each explosive, the price of blasting materials. The more the powder factor increases, then the more of the carton of explosive you need to move from the magazine to the blast site, the more of